Okay, there's lots of words in this question, but it's basically summarized by the diagram. Okay, it's just saying that A is less than B and so on. Now, we're asked for the condition that guarantees that Q, X, and V lie on a straight line. Q, X, V. So this line here is a straight line. And that means it doesn't kind of go here and then goes off on a different direction. That wouldn't be a straight line. Actually, it carries on this in the same way. The diagram's not necessarily to scale because it doesn't quite look like it does here, but that's because, A and B can vary, and we need to find a condition where it actually does. And the way to do this really is to look at the gradient of either Vx, xq, or Vq and compare two of them. So actually you can decide which one you use. In fact, going with VQ is a good shout. So the gradient is the rise over the run. In fact, the rise here is minus d, and the run is b. That's why this one is a good shout, because you don't have to start subtracting things, which you do for the other ones. I mean, I can either do Vx or xq. Of course, you could do Vx and xq together. It's a little bit more complicated, but you can get there. So I think, what should I go with? I think Vx is actually quite, good, because then, um, the run is just c. Although having said that, for xq, the rise is just minus a. So yeah, they're probably similar in difficulty. Vx is going to be, well, I'm going down d, but then I'm going up a. So it's either minus d plus a or just a minus d. And then the run is c. So we require these to be equal, essentially, for it to continue in this along a straight line. Okay, we formed a relationship, which is ultimately what we're trying to do, but it doesn't look quite like it needs to at the moment. But every single answer is two fractions added together to give one. So that's going to be a bit of a hint to try and sort this out. So the first thing I'm going to do is actually, I think I'm going to kind of like add this to both sides and add this to both sides to get rid of that negative. I think that's going to be helpful. So d over b is equal to d minus a over c. I don't know, maybe that wasn't actually that useful, but I've gone with it now. And then I'm going to multiply through by b and by c. So I'm going to get cd is equal to b d minus a, or cd is bd minus ba. Now I know I swapped over the negative. Actually, I'm now going to add the ba onto both sides. And the reason I'm going to do that is I know in my final answer, I've got two fractions added together. So I'm definitely going to need two things added together equal to 1. And that's the next hint, really. If I divide through by BD, then I can get 1 on the right-hand side. So BA over BD plus CD over BD. I can divide both terms separately. I don't need to put it over the whole thing. I can if I want, but this is going to be easier. Is equal to BD over BD. And that thing there is just 1. These cancel and these cancel. So we're left with A over D plus C over B is equal to 1. And that will be the required condition for these these 3 points to be on a straight line. And you've got to try and we can figure out which one it is now, and it's going to be C. Okay, interesting question, a little bit different. I hope you're happy with that.